Okay, so this is the U of O's newly functional experiment NMR machine, and it is June 2nd, 2017, and so these things all up here are the machines that make it work. This is the power supply for the main magnetic field controller. This is the main magnetic field controller. This is the gigantic electromagnet. This is our precision magnetic field readout that reads out the field of around 4,000 Gauss down to about 10 milligauss. This is our main RF synthesizer / sweep generator. Here's the oscilloscope where we read out the actual NMR response on. This is our fancy pants dual channel lock-in that digs the microscopic little NMR signal out from the ocean of noise. This is a wideband signal amplifier that we use to pre-amplify the signal. This is our main magnetic field power supply, and hiding off back here is the local oscillator that allows us to mix the RF down to something the lock-in can work with. And so pretty much the first step is to just go along and turn everything on. This guy takes about half an hour to completely warm up and stabilize, so that's been left on. If it's cold, this guy also takes about an hour to warm up to rated accuracy. It's still actually warm. So just go around, press the on button on everything. And it's about to get noisy. And don't forget to turn the water on, because this magnet will overheat if you don't. So before we tune the probe and tune with the RF section, we're going to just set the magnetic field approximately and let that warm up first. So the first thing to do is we turn the magnetic field enable on. And then we turn the course adjust knob and we can dial the magnetic field back and forth. So once that works, we can turn the remote enable on, and now we can start cranking the field up. We know the field we want is going to come out to about 3.5 volts on here. One, two, three, and change. So now we're going to need the calibration constants. So on the meter, we can go to math, mx plus b. M is plus 1.091163. B is negative 2.407776 milli. So that converts the raw reading into kilogauss. So right now the magnetic field is 3.976 kilogauss, and that's approximately what it should be. And now we can go start tuning up the RF probe. So the synthesizer here has two channels. Channel 1 is our RF and channel 2 is the sweep generator. So we know in advance that the resonance is at approximately 16.2 megahertz, and experimentally 300 millivolt 300 millivolt peak to peak. Works pretty well. It's important to set both of these to, it's important to set the channel 1 to a 50 ohm load. So there's our frequency and amplitude, those are set, and we can turn that on if we want. So now we have to go set up the LO. So this is our LO, and both of these synthesizers forget everything when you turn them off. So we have to set this guy to... So we set this to a little bit below the probe frequency because the lock-in only works up to about 200 kilohertz. Experimentally, 0.76 volt works, and both of these have to be set to 50 ohm load. Totally off. And then we have to go back. And we have to set both channels identically sine waves. And enable both channels. Now that will be feeding out the same signal to both of our down converters right here. So now we can take a look at our lock-in signal here. So right now we're out of tune, so it is very unhappy, and we should turn the sensitivity far down. So we're set at 2 millivolts. And we have it set on angle phase output. We can also set it to XY. So this is our amplitude output, which is being fed to the oscilloscope. So for the purpose of calibrating this, we can just set it to roll. And we'll make sure that is DC coupled. So right now, completely off resonance, that is the signal which is feeding through, and we want to get that to be much, much smaller. So remember, we want to turn the sensitivity of this up by another factor of 20 and have that close to 0. So now the dance begins. So there's 2 input parameters for the probe, the frequency that we can control here, and the resistance, which is controlled through these little potentiometers on there. This is the coarse and that's the fine. And you can see down there is our little magnetic field coil with a little adorably tiny test tube with a couple drops of glycerol in it. So yep. So generally the way it works is we alternately go back and forth, tuning the frequency to minimize the feed through, then tuning the resistance and repeating until it's as small as it gets. After some amount of messing around, we've gotten the probe well enough tuned that we're at the 100 microvolt full scale setting on the lock-in amplifier. And that's giving us 2.5 out of 10 volts maximum. And so from the probe's tuned frequency, we can divide that by the gyromagnetic ratio to get the magnetic field, which should be 3,818 Gauss. So that's what we've got it set to, and we're not seeing the resonance. So we have the coarse field and the fine field, and this guy can adjust the measured magnetic field by about 7 Gauss, and if you continue rotating it, it will go back the other way. a rather interesting movement in there. So now the search begins. So we are ready to start the search, but we can notice that the probe has drifted off into saturation again, just because its parameters have shifted. So we can... So by retuning the frequency ever so slightly upwards, we've brought the feed through back down to a reasonable value. We can also try adjusting the resistance a little bit. Getting better. Getting better. Getting... Okay, so relatively little bit of recalibration and we're back into normal range. Since we're at the 100 microvolt scale, it's no longer in overload. So now we can begin a search. So for this frequency, the predicted magnetic field is 3.819 kilogauss, but we're not seeing the signal. The calibration that we have for the probe is only so good. So now we have to begin searching. So you can take the fine control pot and slowly dial it, and we see the magnetic field starts going up. And eventually it starts going down. So we saw nothing there. Now we set ourselves to the range we were at the top and start going again. So we're continuing to sweep upwards. Oh crap, my bad, I knocked the fine control pot. Okay. There it is. So now that we've got the center of the field tuned to almost exactly where the resonance is, we can start up a sweep that will run across it repeatedly. So this should be set to a ramp. So now the yellow line indicates the magnitude of the sweep. And then the blue line shows the characteristic S shape of the resonance as we run across it. And there we go. There's the nuclear magnetic resonance. That's it.